Welcome to our class today. We're going to look at probability. We'll look at two key probabilities. We'll look at the combinations and permutations and the applications. We'll also fortify on normal distribution and peradventure look at the discrete random variables. So probability is very wide. So you need to know which probability is being sought when and where. So probability to do with combinations and permutations basically looks at the different ways in which you can rearrange your digits. There's what is called a permutation. There's what is called a combination. Permutation is mainly about the order of appearance. Combination is mainly about the content. For instance, you're looking at these letters here. How many are they? They are 4. In how many ways can we pair them? So the arrangement we call that the radical. A pair is 2. So in how many ways can we pair these ones here? Now, you need to understand that permutation is mainly about order. So if I'm going to pair this, I could have AB and BA. Those are different entries. AC and CA. AD and DA. Then you now go to B's. BC and CB. We have BD and what? DB. And finally, we have CD and DC. I've paired them. So these ones in total, 1, 2, 3, 4, 5, 6 times 2, which is 12. Now this is simply a manual manipulation. So to calculate this, we use what is called a permutation. N permutation error. So n permutation error is simply given by the n factorial over n minus r factorial. Now what is a factorial? A factorial is simply a multiplication backwards. For instance, 3 factorial means what? You're multiplying 3 backwards. So starting 3 times 2 times 1. We're getting 6. What is 2 factorial? 2 times 1. We're getting a 2. What is 1 factorial? Simply 1. What is 0 factorial? It's also 1. So let me ask, what is 4 factorial?
So 4 multiplied by 3 multiplied by 2 multiplied by 1.
Excellent. So this gives us 24. At least we know how to do the factorial. So we want to know how many ways we can rearrange these ones in pairs. We're using 2 because it's a pair. In 3s, we'd have put a 3 there. So we're going to use n permutation error. So here we're going to have 4 permutation 2. According to this formula, where there's n, we put 4 factorial. And down, we're going to have 4 minus what? 4 minus 2 factorial. So this will simplify as 4 factorial over 2 factorial. Please don't divide directly there. You simplify first. 4 factorial is what? 4 times 3 times. Whenever we're using a dot in mathematics, it's as good as multiplication. 2 factorial, 2 times 1. When this cancels, we're going to remain with 4 times what? 4 times 3, which is 12. So this is the number of ways in which we can rearrange what? These letters in pairs. All right. So suppose the letters were what? Were 5. There's an E there. And they ask you in how many ways can we rearrange these in threes? So you're going to say the number of elements are 5. And how many ways? Our radical is what? 3. So how are we going to rearrange this? N permutation R. So what are we going to have on top?
5.
5 factorial. Then down.
3 is it 5 again?
5 minus what? Just the difference between these two. 5 minus 3. Remember the formula is this one comes on top and the difference, this minus that comes down there. So here we're going to have what? 5 factorial divided by what? 2 factorial. So what are we going to have here? 5 times 4 times 3 times 2 times 1. Up or down, what are we going to have? 2 times what?
2 times 1.
So when you cancel this, we're going to have 20 times 3, which is 60.
60.
So these are the different ways in which we could rearrange our letters of 5. Now you could,
Collins, just one moment.
yes, please.
The radical 3, I'm a bit lost. Where did you get the 3? On
Like
this last equation.
In how many ways can we arrange them in pairs of 3? The question is mentioned in the pairs of 3.
Pairs of 3, there are 5. There are
The 5 numbers.
letters. 5 letters that you put there.
Yes, the 5. Yes. Then the number of rearrangements. I said in case you're told the number of arrangement, you're told in how many ways can we do what? Can we
arrange
in threes? Can I rearrange it in threes? That's what the question is saying. If it was saying, if the question was saying in how many ways can we arrange it in what? In twos, would have put 2. Yes.
Okay, thank you.
Now you can also use that using a calculator. We found 4 permutation 2 directly to be 12 and 5 permutation 3 to be what? 60. Now a castle calculator looks something like this. So there is, I don't know what calculator you have there, but you can use a calculator to compute. So this is where the permutation is. So you can press 4, shift, and this part here, you are going to have NPR. So press 4, shift, then this pattern, you are going to have, then you put a 2, then equals, it will come as 4 permutation 2. Directly, it will give you the answer, which is what? 12.
12.
All right, let's try now 5 permutation what? 3. Directly in the calculator should give you 60. All right. Then also the radical is there on this calculator. The radical is an exclamation mark, like X exclamation. It is there on top of this button here, just below the shift button. So you can do 4 factorial. So you just press 4, shift, and this button equals. Directly, it will give you 24.
24.
So instead of doing the multiplication backwards, it will simplify.
Collins, using a sharp calculator, where do I find the permutation?
Okay. So those, how many, who else is using a sharp calculator?
I'm also using a sharp calculator.
All right. So for a sharp calculator, we have the following model. Let me just broadcast it as well. Are you able to see the sharp calculator? Something like this, right?
Yes.
So for the sharp, your permutation is somewhere on the number 6. So if you're going to do 4 permutation 2, you're going to press 4, then shift, then 6, then 2 equals, it will give you a 24. You've seen it?
Yes.
So you tell me, what is 10 permutation 3?
720.
720.
720, correct? All right. Then the factorial for you is found on the button n factorial. So n factorial is on button number 4. So you press 4, shift, and 4 again. It will give you, then you do equals. What are you getting?
24.
Oh, great. How about 5 factorial? Let's see. Find 5 factorial on your own.
120.
120. All right. So, with that being said, you would be given a question by the examiner to say a car has 3 letters. 1, 2, 3. So this is a letter, this is a letter, and this is a letter. Enters 4 numbers. 1, 2, 3, 4. This is a number, this is a number, and this is a number, and this is a number. So we are told that the letters here, you can choose any, but the first number here must not be, it must be a non-zero number. Okay, you shouldn't have a 0 here, in short. So how many ways can you come up with a number plate? So how many letters we have in the alphabet? 26. So all 26 here qualify. All 26 here qualify. All 26 here qualify. But how many digits or numbers we have? There are 10. Except here, they have ruled out a non-zero number. So only 9 qualify here. Then here, all the 10. You can have 10 numbers. 0, 1, 2, 3, 4, up to 9. There are 10 digits. Here you have 10 digits. And here you have 10 digits. So in how many ways can we have these ones? Just simply multiplying all these numbers. 26 times 26 times 26 times 9 times 10 times 10 times 10. The answer will be big, but this is what you find here. All right. So He loves such questions, they don't miss. You have a number plate. The first 3 digits are letters. The last are numbers, but the first must be a non-zero number. So ask yourself how many letters we have in the alphabet? 26. All right.
Mm.
And how many numbers we have? There are 10. But this one is a what? Is a non-zero number. But it's a question, some question can be asked. Here it's a non-zero number, but the letters must not repeat themselves. No repeating. So meaning, if they're not repeating, we're going to have the first 3 letters here. 1, 2, 3. Then 1, 2, 3, 4 for the numbers. Letter, 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 number, number, number. If they're not repeating, the only difference here is that here we're going to have 26 chances. Here we have 25 because one has already been taken. And here we have 24 chances. Here, they're not repeating. No, here it's just limited to this one, non-zero number. We have 9, 10, 10, and 10. Are we getting the logic?
Yes.
Where is the 10 coming from?
Because the numbers are 10. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the only numbers we have. Okay, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of them can fit. You can put a 0 here, a 1, a 2. So these numbers, they are all the 10. But here, we've said a non-zero number should not fit here. So only 9 are what? Qualifying on this part here. You get it?
Yeah. I thought numbers go beyond 9.
No, no, no. They are just a manipulation of those ones. So I don't want to spoon feed you. I know you already have the solutions, but I want you to understand this on your own and try to do it. Cars have a license plate consisting of 3 letters followed by 4 digits, assuming the first 3 letters are BAL and the last digit is 3. How many of such number plates are possible? So you navigate around that. So you've been limited. The last digit must be a 3. All right. And the first 3 letters are BAL. How many ways can we do it? Can we come up with such a number plate? So you can do that. All right. So, hello.
Okay. Well, the way he was working this out, okay, for some of us who are behind, we didn't really understand. So I don't know if you don't mind going through it, please.
The first 3 letters are what? B A L. Then we have 4 digits there. 2, 3, 4. The last number is limited to what? A 3. No other number should be there. Okay. So here we have how many chances here? Any number can come here. We have 10 chances here. We have 10 chances here. And we have 10 chances there. Here there's only one number. There's only one chance there that can hold these ones here. What value did you find though? What answer did you find? So in this case, you've been given that BAL should be the first 3 letters. You can't put any other letter there. So it's limited to 1 letter, 1 letter, 1 letter. And the last digit must be a 3. It's limited to 1 number. But here you can put in numbers 0, 1, 2, 3, up to 9. 0 and up to 9. So we're just multiplying these 3 numbers. So 10 times 10, 10. Okay, if you want to show this, you can put 1 times 1. It's still 1. And the last number here is 91. You're still getting 1000. You get the logic?
Yes, thank you.
Yes. Maybe just a question. Let's say a similar question, but if it said distinctive letters are BAL and the last digit is distinctive to 3, would it still be the same?
Yes, it's the same thing.
Okay.
Yeah. All right. Any questions?
So in the question, they always specify, like from the example that you gave us, which says the non-zero number. So that
Yes,
one
yes.
is usually okay.
Yes, should be guided.
Okay. Okay. Thank you.
All right. So can we proceed? Is this making sense?
Yes, please. Yes.
All right, okay. All right, so now we go to binomial. So binomial is a distribution that we use when we want to calculate the probability. So there are 3 characteristics that we have on binomial. Number 1, bi means 2. There are 2 chances that you're going to have for an outcome, a success and a failure. Success and a failure. So there's P and Q. If P is 10%, what is your Q? 90%. The 2 must add up to 100. Number 2, the events occur independently. Number 3, each event has an equal chance of occurrence. There's no discrimination. So the formula for binomial you only need 2 things, the sample size and the probability. So it is given by n combination R times P to the power X times Q to the power n minus X. Now, what is this C? It's a combination. When we go to the calculator, the combination n combination R, which is the same as n R, is given by n factorial over n minus R factorial times R factorial. So for instance, you have 5 combination 3. What are we going to do there? We're going to put 5 factorial here and 5 minus 3 factorial times the R itself, the 3 factorial. We're going to have 5 factorial over 2 factorial times 3 factorial. This will be 5 times 4 times 3 times 2 times 1. This will be 2 times 1 and 3 times 2 times 1. This cancels. And 2 in there is 2. The final answer becomes 10. Now, like usual, you can use a calculator directly. So to use a calculator, for those that are using a Casio, 5 combination 3, let's start with the sharp. You go to 5, then shift, there's a C there on top of the 5. So 5 combination 3 equals, what are you finding?
10.
10, exactly. All right. 5 combination 3 is a 10. So this is the 10 we found. For the sharp, the same place where we're finding the permutation, don't do shift now. Just do 5 combination 3. What are you finding? Those that have a sharp?
10.
10, exactly. So we're done with the lesson. It's very easy. So now they ask you, suppose you have what? You have 5 students. The probability that a student will pass is 20%. So they ask you question number 1, find the chance that no student will pass. B, find the chance that 1 student will pass. C, find the chance that 2 students will pass. D, find the chance that 3 will pass. And E, find at least, at most 2 will pass. Then F, at least 2. So let's start with 0. So the formula for no, they're asking us to find the probability that X is equal to 0. So remember the formula is what? N combination X, then P to the power X, and Q to the power N minus X. So our combination here will be, our N is what? 5. Then no student will pass, means 0 student will pass. Then what is our P? If P is 20%, that is 0.2. What is Q? 0.8. So where there is P, we put 0.2. Where there is Q, we put 0.8. So this 0 will come here. The difference, 5 minus the 0, it will be 5. The 2 must add up to what is on top there. So before we get to the answer, I need you to know how to input the data. So let's do exactly 1 student will pass. So X is equal to 1. What are we going to put there? 5 combination 1. So 5 combination 1, what are we having?
Hello?
Hello, so where do you put the 1? The 1 comes here, right? On the 0.2. Then what do you put on 0.8?
4.
Yes, 4, the difference. So 5 minus 1 is 4. The 2 must add on top. How about X is equal to, before we calculate, I just want you to understand how to do the what? The input. That's where it starts from. So 5 combination 2. Who wants to help us? What are we going to have here? 0.2 times 0.8. So what comes here?
2.
2. What comes there?
3.
3.
Sorry, Collins. I just want to know the 0.8, has it been given? I'm trying to understand, and how we're getting the powers, the 2 and the 3. Hello?
So we're only given a P. The Q you need to calculate on your own. If P is 20%, so 1 minus 20% is 80%. That's where the 80% is coming from. So if you're given a 10%, the Q should be 90%.
Okay.
Is that clear?
Yes.
All right. So
The
here
percentage out of 100.
the percentages. So what is 5 combination 0? On the calculator, what is 5 combination 0? 1. A number combination 0 is 1. What is 0.2 to the power 0? It's also 1. A number to the power 0 is 1. What is 0.5 to the power 5? 0.8 to the power 5?
Right.
0. Point what?
32.
0.32. 32 what?
7.
327. So the final answer will be 0.327. Then here, what is 5 combination 1? It's 5. In number combination 1 is that number itself. What is 0.2 to the power 1? Is 0.2. What is 0.8 to the power 4? Quickly. 0.8 to the power 4. 0.4096.
4096.
So when you multiply all that, the final answer of what? The same 4096. Because this is 1. And here, what are we finding? 5 combination 2. What are we getting? 10. 0.2 to the power 2, 0.04. 0.8 to the power 3. That is 0.512. So when you apply this by all that, what are you getting? 0.2048. All right. Now, listen to me carefully. So if you're asked what is at most 2, it is 2 and below. What is at least 2? It is 2 and above. So if you're asked to find at most 2, it means you find the probability of 0 plus the probability of 1 plus the probability of what? Of 2. You add them. At most 2. So we're going to add the answer we found, this plus that plus that. If they say at least 2, it means 2 and above. 2 and above. Two and above. So now, in this case, we know the sample size is 5. So 2 and above is what? 3, 4, and 5. So instead of redoing that, just subtract 1 minus the probability of what we've already found. What is unwanted? 0, 1, and 2. Okay. The answers we found, we subtract from 1, we'll get the remainder. So quickly, your homework will be to do the question here, number the question I broadcasted. So you should try this question number C. I expect this work here. Your P is 5% and your N. What is your N? Is twice. Okay.
It's 6 years.
6 years. No, the radical.
Hmm?
Okay, twice in 6 years, yes. So N is what? 6 and R is 2.